Hello and welcome to the last talk of the day. I hope you guys still have some energy left. We're going to talk, our talk is called actually From Zero to System on a full disk encrypted Windows system. So we're actually going to explain several vulnerabilities which allowed us in the end to go from zero to system level privilege on a Windows Windows full disk encrypted system rather. The mandatory introduction. First of all, hi, I'm Tom. I work for a company called Dimension Data in Belgium. I'm the security governance team leader, so we have a couple of consultants in my team who regularly do penetration testing and so forth. We have some specialties like testing ATM systems, cache machines, but also testing Windows environments. And it's actually in that last one that we actually resulted in this talk during our R&D. I'm mostly occupied with, let's say, the more boring part of security nowadays, being security compliance, regulations, and so forth. I have a Twitter handle, nothing special about that, and I'm actually also one of the co-organizers of BruCon, which I hope most of you people know. Lastly, just want to mention it, that we're always looking for some great talent, so if you feel up to it, come and see me afterwards.
Hi everyone, I'm Nabil and I'm a security researcher and a penetration tester at Dimension Data. I'm part of Tom's team. I love to break things, I love to see how everything works, I love to find vulnerabilities in the end. I also have a Twitter handle and also a blog post. After this talk, details will be released about the vulnerabilities on my blog post. So let's get started. First, the inspiration. Why did we actually go into this research and how did we came about to doing this talk eventually? So, in late last year, in November 2015, there was a talk held by Ian Haken on Black Hat. And the title was Bypassing Local Windows Authentication to Defeat Full Disk Encryption. So the title itself already is very intriguing, so we went to the talk, and what he eventually demonstrated was a new way to defeat full disk encryption. He used a rogue domain controller, and he used that rogue domain controller to poison the credential cache. And Microsoft eventually labeled this vulnerability as a Windows security feature bypass. So, what does this patch that Microsoft released actually hold? So what they did is implement a trust relationship before the local credential cache is being updated. And it was patched on Windows Vista up to Windows 10, and also for the server versions for Windows Server 2008 up to 2012, with the exception of Windows XP and 2003, so they are still vulnerable if you find any systems in your environment. So a little bit about BitLocker, because we are going through the prerequisites of these vulnerabilities. So first of all, BitLocker has 3 ways of implementing it. The first one is TPM, which uses a built-in chip on the motherboard, which stores the secret key in order to decrypt the hard drive. Then you have the pre-boot pin, as the name suggests. You use a pre-boot pin to actually enable the authentication, the decryption process. Then you have the USB key. Then you have to use a physical USB thumb drive that holds the secret password to enable to decrypt the hard drive. But we will only focus on the TPM. So a little bit about the TPM, what the TPM actually does. It stores the key on the motherboard, on the chip. It doesn't require any user access, so you can just start up your laptop and the hard drive will be automatically being decrypted on the fly. And once it's booted up, that's the screen you will see, just the Windows login screen. It's the first and the only line of defense. So also a little bit about trust relationship, what it is and how it's actually used for. So just the computer account password, so every machine has a computer account password. And it's used to actually verify the trust between a domain controller and a client. And it's randomly generated every 30 days. And 2 versions of the password are stored on the client side. So there's an old value and a new value. The old value is stored is the password that is older than 30 days, and the new value is obviously the one that is currently in use. This is because if the client doesn't connect back to into a Windows domain within 30 days, it can still fall back to the one that was used 60 days ago. And the key, so the passwords are being stored at the following registry path. In order to actually access those passwords, you need system-level privileges. So we will get into that later. So first of all, we had to bypass the patch. So the patch that Microsoft released after Ian Haken's talk at Black Hat, so MS15-122. So that was our first hurdle. We had to actually bypass the patch that Windows implemented. We weren't really convinced that Microsoft really patched it very good. So we had to look at the difference in the communication. As you can see, there are two screenshots, and the first one is a legitimate domain controller, which has a specific ticket that is used is a TGS request and a TGS response, which are basically service tickets. And if we use a rogue domain controller, so a fake domain controller with the same domain name, we get an error. So the error says it's service principal name unknown. So if you look into details into the packet of the packet that was sent by the domain controller, we can see that the real domain controller sends back a ticket, an encrypted part, which is actually a ticket, a Kerberos ticket, and the fake domain controller doesn't reply back with anything. So a little bit about SPN. So SPNs, what MSDN says is SPNs are used to support mutual authentication between a client and a client application and a service. A service principal name is associated with an account, and an account can have many service principal names. Very generic description, and SPN can be formed with a service /host or a service host with a port. We will dive into that during the demo. Demo time.
So what Nobel is now actually going to demonstrate, we've set up two VMs. This is the VM of the client. And you'll see that somebody already logged into it. So this is actually, let's say, the situation that you'll end up with. In an environment where you have a BitLocker encrypted system with TPM, you boot it up, and this is where you end up. The login screen, the log screen.
So first of all, we need some information that we can gather from this screen. For example, we know that the user is called domain user, and domain is domain. Yeah, we weren't really inspirational on the names. Then another thing you need to know is the name of the machine itself. So you can do that with just using the other user, and then you know client is the name of the machine.
Again, we weren't very creative when we selected client as a name for the system.
So let's go into our domain controller. So this is our fake domain controller, which is basically in the same domain. So the domain is domain. So we made the domain controller with the name domain.local. Simple. So first of all, we will create a user, the same one with the information we just gathered, so domain user. Just to demonstrate, we did the password test.
Yeah, if you set a very low password policy, right? A very easy one just for demonstration purposes, because it's your control, it's your domain control. You can do whatever you want with it.
So we created a user just to demonstrate what happens when you just log in with the password. So it says, the security database on the server does not have a computer account for the workstation trust relationship. So basically, the client says, I don't trust the domain controller, so I won't let you actually log in. But to bypass this error, you just create a computer account or a computer object, the same name. There you have it. Then you move on to edit to actually modify the properties of that object. So properties, SPN.
SPN, yes.
That's the SPN that I explained earlier, that is used to actually support mutual authentication. So we just do host, client, and host. Then the full domain.local. And now,
first reset the password.
Reset the.
So he's now going to the domain user account and actually mentions that the password is expired. So by leaving the flag, user must change password at next login, you actually expire the password.
So yeah, it will display us. So the password has been changed. We go back to our client. Type in password. It says the user password must be changed before signing in. Say OK. We do, for example, B. So change your password. Your password has been changed. We didn't know the password before we started this demo, so now we change the password to the one we know. So now we just disable the network adapter. So we force it to use the local credential cache, which is now poisoned.
And in everything as well.
We have access.
You access the system.
So let's dive more into detail about in the communication between the fake domain controller and the client. So first of all, there's a client, we don't know the password, but we have a fake domain controller with an expired password. The first the client does is request for a TGT, so a ticket granting ticket, from the domain controller, and the domain controller says, sorry, your password has been expired and it must be changed. So the client says, OK, I know the password has been expired, but it does request another ticket granting ticket. The fake domain controller knows it already said that the password has been expired, and it replies back with a ticket granting ticket with the expired password. The client just decrypts the ticket and with the typed password. Next, what it does, it uses that ticket that it received from the fake domain controller to send the new password with encrypted with the new password to the fake domain controller. And now, the password that we just set, for example, in our case, was B. The domain controller, the password on the domain controller side is now B, but it's not changed yet on the client side. So if the password policy on the domain controller is accepted, which in our case did, it will say either a success or a failure. This is the part where Microsoft tried to patch the system. First of all, they sent an initial request for another ticket granting ticket with the new password. The server replies back with the ticket granted ticket. Then the client requests a service ticket together with the ticket granted ticket that it received. And the fake domain controller replies back with an invalid service ticket, because the service ticket is based upon the machine password, which we don't know. So it's something that we don't know, it's something we can't control, but it does send back an invalid service ticket. Then the client changes the password, and after it changes the password, it verifies the ticket. So eventually, conclusion, the patch that was implemented by Microsoft, it only checks if the service ticket has been received. If it does, then it changes the password. It only validates it after a password has been changed. So the damage is already done. So we have access to the system, we can do anything we want. It was patched as MS16014 with the CVE number 2016-0049. And the suggested workaround that Microsoft mentioned was disable the local password caching. But that essentially turns your laptop into a desktop, which is not really an option for many people. So, and it's all patched on all supported versions of Windows. Blue box. So Ian Houcken actually automated this attack in a very neat way. And both exploits, so the one we found and the one he found, are now in a GitHub repository that can be used, and it's written in Python, so it's an easy language, so you can actually manipulate it the way you want. The password change happens in less than a minute, and it's portable in a Raspberry Pi, so you can just just plug it in, change the password, and do your thing. Another functionality that he also implemented was the zero downtime attack, which essentially means that the targeted client machine is never going to lose connectivity. So it will be able to change the password without any loss of communication in the meantime. So kudos to Ian Haken for making this automated, and you can just get it from there.
So, thank you. So what's next? Yeah, essentially, as you saw, we were able to access any files that the user can access to. Logically, you have the same access privileges as the user has. But let's say in a typical corporate environment, you'll find yourself with only limited user rights. You will not have administrative local privileges. So while we could get all the passwords and documents and anything that's stored on the full disk encrypted system, you're still limited as being a user. So we were looking for a way to do privilege escalation, because let's say in a complete picture, you want to do the more fancy stuff, being installing your remote access toolkit, for example, disabling even the full disk encryption system altogether, you need admin privileges. So we looked for another way to actually do that. And as you saw before, we were able to abuse the trust relationship, or at least the lack of validation of trust relationship, between a client and a server. So actually, that alone got us thinking. Thinking like perhaps there are some other ways, there are some other typical communication that Microsoft operating systems do that do not validate the trust when they actually communicate with a server. So we have a working Active Directory setup, we have a client and a server, and so we were thinking about these various functionalities. And we were thinking about group policies. First of all, group policies, the advantage of a group policy is that it works on any system which is part of a domain. So it does not require you to have anything previously configured, or it does not require you to have any vulnerable software on there to start your privilege escalation attack. It's supported, as I said, on any Windows system which is still under support, so it's actually a good entry point. Small and quick introduction about group policies for the people who are not familiar with that. We'll keep it very brief. There are actually two types of group policies which you can set. You got the computer configuration and you got the user configuration. The user configurations are applied when a user actually logs into the system. So whenever your system is booted, it logs in, and then the GPO settings are applied. A computer configuration is actually already applied pre-authentication. So whenever your system is booted up, the GPO will already be applied. On the user side, you'll see that GPOs are actually applied either with system privileges or with local user privileges, while on the computer side, you'll see that it's always applied with system privileges. On the left side, the user configuration, you see it's going to use the user account password to actually retrieve the GPO update or the GPO information, while on the right side you'll find the computer account being used for that. Logically, we don't have the computer account password, so we stayed away from there, and we used the GPOs related to a user configuration, so the user GPOs. Quickly, how group policies actually work for the people who are not familiar with that. It's actually very straightforward. So the first thing a client will do is going to search for its nearby domain controller. It does this basically via DNS, essentially doing a DNS request, finding the nearest by, or let's say the highest priority domain controller in his network environment. He's then going to do a remote procedure call to actually establish a secure connection. You can see there's a small icon over there. That RPC connection is established with the user password, so the one the user just typed in. It continues along with some various LDAP connections, actually retrieving a list of all the GPOs on the system, and then going to get, via the same LDAP connection, he's also going to get some information about the various GPOs on the system. And then lastly, he's actually going to read the GPOs. The last part is typically being accomplished pure via basic SMB connections, because it goes to the share, the sysvol or the netlogon share rather, to actually retrieve the actual configuration of the GPO. So again, as you see the different icons up there, it's all using the user credentials. So it's not using anything else to authenticate to the server. Eventually, once he retrieved everything, he'll actually apply the GPO. So that got us thinking, and it actually resulted in our first attempt, very straightforward. We created a new GPO. We applied it to the user we just talked about, the domain user. And essentially, what does the GPU does? It actually has 3 tasks in there. There are only 2 displayed over there, but there were 3 in them. The first one is download a file, so get a file from the domain controller on my personal system. We use Netcat for that. The second scheduled task, which the 3 tasks are actually programmed to run sequentially. So the second scheduled task essentially will run Netcat, but then with the user privileges of an anti-authority, of a system user. And then the last scheduled task in there will essentially just connect to the service we just created in the previous scheduled task. That's essentially what's being done over there. Basic and standard Windows functionality. So we tested it out. As you can see on the screen, it's a Windows 7 system. So we tested it out. We ran the command which is called gp-update, which forces an update of the group policy, and it works. To our surprise, it worked from our first attempt. So the client did not validate any trust between the client and the server. The only trust it relies upon is the fact that you know the user's password. And logically, we've set that already with the previous attack, so we were able to do that. As the slide now shows, it's more or less expected behavior in some sort, because all the communication that we saw earlier is using the credentials of the user. Never in all this communication, the client is actually going to validate that the server he's talking with is essentially a server he should trust, is essentially the domain controller where he normally is part of. So he actually doesn't really validate the trust, again, for GPO updates, and because they're applied at system or anti-authority level, you actually get a very nice privilege escalation. We got a demo in there in a couple of slides, so we're going to show you something else as well. So we reported this vulnerability to Microsoft, who acknowledged it. We were able to reproduce it in their environment. But we actually continued along, and we searched a little bit further also on the internet, and we came across a post from Luke Jennings from MWR Labs, who about a year ago, in March of 2015, already found, first of all, a number of vulnerabilities in the way that GPOs are being handled, where you could actually do a man-in-the-middle attack on the communication between the client and server, and resulting in some privilege escalations. But one of the conclusions he actually drew at the end of his blog post is the fact that even from Windows Vista systems and onwards, if you know the user credential, you can always elevate your privilege to that of a system, because the way that the communication, the way that the GPO is being transferred, being via SMB connections, if you know the password of the user, you can reassign the signing, you do all the authentication, and actually get your own policy in between. So for us, we actually realized, like, did we actually find something new? Microsoft acknowledged it. Microsoft said to us, "Yeah, thank you for reporting that to us." But for us, we also asked them, like, well, is this actually new information for you guys? Because we actually found the blog post. It's general. I mean, everybody can find it. Why didn't you handle it before? And it also got us thinking, like, perhaps Windows, or Microsoft rather, already fixed it in a more recent version of their operating system, and they still need to apply the patch on older versions. So that got us thinking and said, okay, let's set ourselves a new challenge. Let's take Windows 10, do the exact same thing we did before, do the authentication bypass, reset the local cache password, and run the scheduled task. And while actually the GPO update command, first of all, gave us the response, the user policy update has successfully been applied, it actually then spawns an error message. Windows failed to apply the group policy scheduled task settings. So we were thinking, like, okay, good. Microsoft has fixed it in Windows 10. They just need to backport it in Windows 7. They knew about it. They fixed it in their latest operating system. So we were actually happy about it. So when we actually looked into the error message, which perhaps could give us a clue why the update failed, we started to look at the event manager, and we came across an event ID. You also see the user ID over there, which, by the way, is the user ID of NT-Authority, of the system user on any Windows system. And it again gives you an error message, error 2. We searched on the internet, we searched on multiple places, MSDN, forums, and all that. We were unable to find somebody who can explain to us why this error message was there. So it had nothing to do with an unauthenticated or an error message to do with authentication failure or so forth, or trust validation failure. We didn't know why the error was there. So we started to compare. Okay, it worked on Windows 7. Why doesn't it work on Windows 10? So we looked at the communication, and remember I talked about how GPO updates work. You have DNS, you have RPC, and then finally you'll have several LDAP queries which are being executed. And this is the one which is being done on Windows 7. And you'll see it actually goes through there, and in the end he'll actually get an identifier of the policy he needs to apply. When you look at the exact same communication on Windows 10, you actually see in the end, after he receives that information, he does another LDAP request using an SID. Using an SID, he's going to connect again to the LDAP. He has a secure connection to the LDAP server, and he's going to query the LDAP database rather with an SID in there. And the SID is the one of a user. Again, small and quick explanation of what an SID is actually all about. So an SID is formatted like this. The first 4 parts, so the S1521, is generic for everybody. It's always the same. And then you have a part which is called the domain security identifier. The domain security identifier is actually the machine ID the first time you create a new domain. So if you take, let's say, a Windows 2012 system, any Windows system will have an ID. But if you promote that Windows 2012 system to a new domain, it will actually take the machine as ID and use that as the domain security identifier. So every object in that domain will get that domain security identifier. Added to that, you'll find the RID, or the relative ID, which is essentially just a sequential numbering to assign to every object in your Active Directory environment. There are some fixed ones, like, for example, 500 is always the admin, and there are a number of others, for example, for certain groups, but it's essentially just a relative ID. So we were then challenged, and we were actually looking for a way to set this as ID, because we were actually already thinking that perhaps it only has to do with the fact that the SID we have on our ROG domain controller does not match the one we have for the system that we are attacking. Logically, because we set a completely new domain, we've set up a completely new environment, the IDs will never match. So we looked into the possibilities, and actually a number of them, but none of them were actually easy to do. So what can you do? You can use sysprep, but sysprep will actually only generate a new ID. It will not allow you to actually set it to your liking. You cannot choose which SID will be next. Running SID will essentially just give you a new SID. Sysprep, rather, will give you a new. There are some commercial tools out there. We're not going to talk about it. You can also offline edit the NTDS file, so actually the Active Directory database. Kind of tricky and quite prone to errors. And for demo purposes, it wouldn't all be that good. I'm sure you don't have the time for that. And we actually also found a way to use a Samba server, so the more equivalent on Linux, where you actually first install it as an NT4, in an NT4 mode, the real old Active Directory environment rather. There you can still set the SID and then do the whole promotion to a full primary domain controller, and then you still have control of setting the SID. But again, it's going to be lengthy, it's going to be prone to errors. So actually, Mimikatz came to the rescue. When we were creating this talk, back in May, when we were creating the slides rather, we were actually looking for a way to demonstrate to you guys how we could actually continue with it. As I said, demo will follow. And we came across an update from Mimikatz, created by Benjamin, who is actually here, by the way. We invited him. And the newest version, in the beginning of April, actually had a new module in there, which is called the SID module, which allows you to manipulate, look up, query, and actually change SIDs of objects in the Active Directory environment. So we're, okay, good. Let's try this out.
So I'll be guiding you guys through the demo again. So as you can see, we are already logged in. And let's just, for the sake of completeness, let's just run the gp update command and see what happens. So gp update, we will target the user configuration and we will force it.
So it's now just going to refresh the GPO configuration you have for that particular user. Let's hope we pray to the demo gods that it works. We don't have a backup video, by the way.
Yeah.
So this is it. If it doesn't work, sorry. So you see this exact same error message actually that we've shown you earlier. He was unable to apply the scheduled task.
So before we go to our rogue domain controller, we need some information. We need the SID of the user that is on the client's PC. So this is the SID, as you can see. Now we go back to our fake domain controller. So just open Notepad. Let's go to @cedit. Just to show you guys that the SID is completely different from the one we want it to be. So, as you can see, we want it to end with 0014, and not only that, even the whole part is totally random, so we need a way to set it. So, as Tom said, we will go to Mimikatz, command prompts, Mimikatz, then run it as.
So first, you'll have to type in the command privilege debug to put it in debug mode.
You have to patch the NTTS service, so that's been done. Now we will set
modify, yeah.
Use some. It's domain user new.
So again, if everything goes well.
Yeah. It goes well, so let's check it again if it's really modified it. Refresh. Object. And indeed, it did change to the one we want. So we go back to our client PC, we run the command again, and let's hope it works.
Yeah, let's hope, let's hope. There you go. We enter authority.
So as you can see, we are running a system. We have full control over a full disk encrypted system. So
yeah, it's game over.
Yeah. So let's go back to the slides.
Yeah. So yeah, well, we thought that Microsoft tried to fix it in Windows 10. Apparently, they did like one more check, which is very easily circumvented. You could have also opted to change it, for example, in a man-in-the-middle kind of situation, because you do know the password, so you can change the LDAP communication if you want. Since we have a working Active Directory setup, it seemed for us easier to do this. So the conclusion, there's actually, Microsoft released a patch. Thank God for that. 2 weeks ago, actually, in the patch Tuesday of June, you got some MS numbers and CVE numbers you can read. And it actually now validates the trust before it actually applies the GPO. But it actually took them 8 months to patch. So when we reported the vulnerability, we were actually trying to get some information from Microsoft as well, like, okay, when are you going to patch? When are you going to patch? And the reason they actually said to us, like, of course, we had a fixed deadline being Hack in Paris, where we're going to show the vulnerability itself. So they also had a fixed deadline, which we could not move. But they said to us that anything that changes anything to the communication of GPOs, particularly, is taking them a lot of time to fix, because they're very afraid to break backwards compatibility. So, as I said, it took 8 months, and then this happened. On Wednesday, after the patch, the internet was full of people really shouting out to Microsoft on various forums, various locations, saying like, hey, you broke my GPO configuration in a corporate environment. What's happening? What's happening? So you saw that it was a number of people who actually shouted out. And what was the issue there is that while Microsoft did add an additional trust check before it applies the GPO, they forgot to mention to the people that the computer account we talked about earlier, the one that's used to validate the trust relationship, is now going to be the one that retrieves the GPO. So you also have to give that account privileges to the GPO. If you don't change the privileges of the GPO, the update will unable to actually get the files and actually read the GPO configuration. So they forgot to mention that. A couple of days later, there was a knowledge base update where there was a clear indication, please update your GPOs and assign the necessary privileges to those type of computer objects, and then your GPOs will work again. So, well. Our talk as well, we described it, and there's actually only a brief slide here, but we just want to quickly touch on the subject. How can you actually now use this to recover the original password? Because in some sense, we've changed the password during the password cache update, rather. And how can you actually use this to recover the original password back again? So there's actually one very nice feature which every Windows operating systems, rather, has configured by default, which is actually says that it's going to go in hibernation when the battery of a laptop is going to critical mode. By default, it's set at 5%. So whenever your battery arrives at around 5%, it will actually go into hibernation mode, which is very cool because hibernation mode essentially dumps the contents of the memory into a file, hyperfile.sys, which is actually a very nice way to get the contents of the memory. So imagine yourself in a situation, Valerie explained it earlier, where you leave your full disk-encrypted laptop back at the hotel, and it got like an access control, physical security, like the badge systems, right? You can easily clone badges, it's been demonstrated, you can easily get the ID and actually get into the room. You just wait for the laptop to die, you steal it, you wait for the laptop to die, it can take some hours, okay, it's a lengthy process, and you wait for it to die and go into hibernation mode. You then actually use our tag to bypass the local authentication, so you actually get onto the system, you reset the local password cache, we elevate the privileges, we've shown that, you extract the hyperfile.sys, and there are a number of ways which are very known to everybody, you can find them on the internet, to actually convert the hyperfile.sys to a more readable format. Again, Mimikatz plays a very important role there, thanks again. And you can actually get the contents of memory, which was in the memory when the system was in a locked mode, back on you to control, and actually extract an encrypted version, or actually in some cases, a plain text version of the original user's password. You reset the password to the original users, of course, after you installed your remote access toolkit or whatever malware you want, and just place the laptop back again in the room and lock the room. The person, the victim itself, will come back to his laptop. He will not notice anything would have changed. His local password is still the same. It was a full disk encrypted system, so you would not assume that something was altered to the hard drive or anything, but somebody actually installed anything he wanted without you knowing.
So a little bit about the timeline. So as you can see, there are two bars. So the top one is the one with authentication bypass, and the lower one is GPO. The top one is also the one, the reactions we did. For example, we did mention, like we bypassed the patch on November 18th, and Microsoft responded back on the November 25th that they acknowledged the vulnerability. But we don't want to end this talk without a bombshell, and here it comes. So the February patch that they fixed for MS16, the one that we reported, has already been bypassed by us again. So it's still vulnerable. So, takeaways.
Takeaways. So the takeaways we actually want to give you guys as part of this talk is, first of all, when we attended the initial talk of Ian Hawking at Black Hat, it came to us as a complete surprise that the trust relationship isn't validated when you do a password reset. When he actually, while he used some other ways to actually demonstrate that, he already established that the trust relationship isn't always validated. And it came as a surprise to us as well. And the only thing we want to say there is do not assume that even an operating system which has been here for whatever, for a very long time, like Windows, actually implements a trust validationship at every possible layer. So do not rely on that.
Then they don't take physical security for granted. As Valerie said, there are a number of ways to get your way into restricted areas. And even if your laptop is secured, full disk encrypted, don't think it won't be able to be manipulated in any way. Yeah.
As I said already, backwards compatibility is actually a challenge for Microsoft in many, many cases. They do really want to keep that backwards compatibility, but it's also a challenge for them to fix certain security issues which get reported because it takes them much more time to actually validate it in multiple configurations.
And another thing, I think, one cool thing is that we actually bypass authentication, gain privileges without rewriting any single line of code. So why try difficult when you can do it the easy way? And yeah,
absolutely. So we definitely want to extend our kudos to Ian Hawking, who was our first inspiration for our research, and definitely also to Benjamin Delphi, who created Mimikatz, which is an awesome tool. If you haven't looked at it, please do. It's really great.
And last, third time's the charm. I think we bypassed the authentication process 3 times already. So in November they fixed it. In February they fixed it. Now they're planning in July. However, 2 days ago we received an email that they won't be able to hit the July deadline. So it said something like late summer. They will give out some details or not. So.
Yeah, so in July, normally the 90-day disclosure deadline, which typically a researcher will set, will pass. We've already been quite friendly with the GPO updates. We're probably not going to release it in a 0-day format anyway, but still, you do want to follow up on these things. That's about it. If there are any questions, we're more than happy to answer them. No questions? No? There you go.
Hello. What about traces in the Windows event?
Can you speak up a bit?
I want to know if there is any traces of your DC rogue conversation in the Windows event.
Windows event. I'm sorry. I didn't get that. I don't really get the question, to be honest. Just repeat it.
When you do some response on incident,
yes,
you look up for event files.
Yes.
And does this attack leave a lot of traces?
No, traces. Well, actually, not really, because essentially it's basic Windows communication, right? You haven't seen any error during the demo. You're just doing whatever the system wants you to do. So if everything goes well and you don't do the intentional errors we just generated as a demo purpose, you will not see any you will not see any errors. So your event log, if there's even an error in the event log, you can clear it anyway, but you won't see much.
Yeah, I think we're using basic Windows functionality as it was intended. So I don't think we will see any errors because we are not using any buffer overflows or any kind of exploit techniques to actually trigger something. So it's pure functional Windows functionality that can be abused in malicious ways.
Okay, thank you.
Thank you.
About the hotel scenario.
Yes.
So if the computer with Windows stayed shut down and not hibernate, and you come to the hotel room and see this shutdown windows, are you still able to recover the password?
Yeah, actually it is, because if it depends a bit how the configuration is, but if you use TPM, it's the trusted platform module, so BitLocker with TPM, it's going to boot up to the login screen without anybody actually having to user interact with the system.
No, I think what
But is still password stored somewhere in memory? Because you said you will recover it from the sys file, right?
Yeah, exactly. For example, when the PC goes into hibernation mode, it dumps the contents of the memory onto the disk. So if that ever happened in the past, and the password has been changed during that time, yes, we can recover it. But if it never went into hibernate, ever, then it's no way to recover the password for us. So.
And also, because you mentioned if the system is shut down, if you boot it up to the log screen, will there already be something in memory for us to dump into hibernation? I think that's the question. It depends. There is some software, if you do like, which is going to run in the background, which could still result in something into memory, but it's going to be very rare. If the system is completely shut down and you start it up, end up at the lock screen, or login screen rather, you won't have that much in memory yet, so you won't have that much to dump either. That's true. But I guess most people will put it in standby mode anyway, because otherwise, booting it all the time, yeah, it's a hassle. I know.
Yeah, I agree, okay.
But I agree, yeah, sure. Well, we'll be here today and tomorrow, of course, so if you have any questions, otherwise you can reach out to us, Twitter, or anything, and thank you.